In today's lesson, we are going to talk about simplifying algebraic expressions. Before we can talk about what simplifying is and what the rules are for simplifying, though, we need to review some vocabulary related to algebraic expressions. What you're looking at on your screen right now, 3x plus 4 minus 2y plus 1 minus x, is an algebraic expression. Algebraic expressions are made up of some different pieces, and those different pieces have names. They have vocabulary that go with them. We need to know what those names are because they are going to come up when we're talking about the rules for simplifying and what it means to simplify an algebraic expression. First thing that we need to remember is that an algebraic expression is made up of terms. So a term is just a piece of an algebraic expression that is separated by addition. So every time you have an addition symbol, you have a new term. Now, some of you might be looking at the algebraic expression on your screen and thinking, wait a minute, there's some subtraction in there, not just addition. You have to remember that subtraction can be rewritten as addition. Remember in our unit on integers that we just finished, we said we can turn any subtraction problem into adding by making the second number its opposite. So we could take our algebraic expression and we could rewrite the whole thing so it's all adding. It would look like this. 3x plus 4. The subtraction we could turn into addition by saying plus negative 2y, make the second number its opposite, plus 1, and then the same thing again at the end, plus negative x. So this really is a giant adding problem, and when we're done, we end up with 1, 2, 3, 4, 5 different pieces that we're adding, which means this expression has 5 different terms. The reason that's important is because what we do with the terms is going to be part of our process of simplifying. One of the things we do when we simplify is we look for like terms, because like terms can be put together. Like terms are terms that have the same variable. So in our expression that we were just looking at, we have a term that is a 3x, and then we have another term down at the end that is a negative x. Those both have an x in them, so they are like terms. Now we do have another place where we have like terms, but they're a different type of like terms. So we say like terms are terms that have the same variable. Having the same variable can also mean having no variable. So that means that the 4 and the 1, they have no variable, which means they are also like terms. But because they have no variable, they also get a special name. So they are like terms, but they're a special type of like terms. They are called constant terms. Or sometimes in algebra, we just call them constants for short. The reason we call them constant terms or constants has to do with the fact that they don't have a variable. So using our first term as an example, 3 times x, the value of that term changes based off of what I fill in for x. If x is a 1, that term is 3 times 1, or 3. If x is a 2, that first term turns into a 3 times 2, or 6. So it can change value based off of the variable. The 4 and the 1, they don't have a variable, which means those terms will always be a 4 and a 1 and nothing else. They stay the same, or they stay constant, which is why we call them constant terms. So constant terms are like terms, but they're like terms that don't have a variable. So simplifying involves putting together the pieces that you can put together in an expression. So we highlighted our like terms. We have a couple of like terms in orange and a couple of like terms in green. So we can combine like terms. So combining like terms means actually doing the adding or the putting together of the like terms. But in order to do that, we need to pay attention to one other thing, which is where one other piece of vocabulary comes in. I'm going to borrow our 3x and our negative x. So commutative property says we can add these pieces in any order we want. So I'm going to grab that beginning piece and that ending piece, and I'm going to rewrite just those pieces because those are like terms. So we can add those together. In order to add them together, we're not adding the x's. The x is going to stay there. What we're actually adding is something called the coefficient. So the coefficient is the number in front of the variable that tells me how many of that thing I have. In other words, it is, since usually, well, always with a coefficient, we will be multiplying. So it is the factor of the variable. In other words, it's what the variable is getting multiplied by, which again tells us how many of that thing we have. So when we say 3 times x, we're saying, okay, I have 3 x's, x plus x plus x. You have to remember, a factor is a number that we're multiplying. So since we have two like terms we're looking at putting together, we have two coefficients. So the first one, the coefficient is 3, because the x is multiplied by 3, or I have 3 of them. The second one is a little trickier to see, so you have to ask yourself, well, if I just have an x, what am I multiplying by? So if you just have an x, what's going on is that we're actually multiplying by 1. But the multiplicative identity says that anything times 1 is itself. So x times 1 is just x, which is why we don't usually write out the 1. We just have to remember that it's there. So a term will never be missing its coefficient, but sometimes the coefficient isn't written out if it is a 1. So these two like terms each have their own coefficient, 3, and in this case, -1. The reason we talked about coefficients is because coefficients tell us how to put the expression together. So since this is an adding problem, what I'm actually adding is the coefficients. So I could come through and I could do 3 plus -1, which is 2. And since what I'm counting is x's, it's going to keep the same variable it started with. So 3x plus -x, or -1x, what it actually is, would be 2x. So I can take those and I can put them together. So I could also do that with my other like terms for my expression. I had two constant terms, a 4 and a 1. So I could take the 4 and the 1 and I could put them together to make 5. So that means I have everything gathered up. All of my like terms are gathered up that I can gather up. So my 3x and my -x turned into a 2x. So that was what was originally the orange parts of my expression. The 4 and the 1 got gathered up into a 5. That was what was originally the green parts of my expression. Now there is one term left that wasn't highlighted, and that is the -2y. because there's nothing else with the y in it. It doesn't have a like term. It's just kind of sitting there. So there's nothing that it can be combined with, but it's still part of the expression. So when we're done, we would just rewrite it. So our expression we started with, when it's simplified, is 2x plus 5 plus negative 2y. Now there is a little bit of, there are some unspoken rules when you're working with things in algebra. So this is our simplified expression, but in algebra we like to clean that up a little bit. There are a couple of unspoken rules. So these are rules that they're not laws. You don't have to follow them, but they're generally things that most people do in algebra. So one unspoken rule is that we like to put our terms with variables first in alphabetical or ABC order. So that means our constant term will always be last. And a lot of times when we're writing things out, we also try to avoid double signs. So we'll talk about that in just a second. So if we were going to write our final answer to this using the unspoken rules, the 2x would go first, ABC order. And then the negative 2y would go next. And then the constant would go last. So that's kind of putting things in order. This avoid double signs has to do with what's happening right here. So we don't like to put two symbols in a row like that. So we had changed our subtraction to addition to make it easier to see where the terms were and which terms are positive and which terms are negative, so that we didn't lose track of anything that was supposed to be negative. When we're all done, though, we like to clean that up. So plus a negative, if you wanted to rewrite that with a single sign, you could change that back into subtraction. So 2x minus 2y plus 5. And this would be a nice cleaned up final answer. So that's a little run through of all the vocabulary that's involved in simplifying an expression. There is a little bit more to this. There's actually one other step that sometimes happens when you're simplifying, and it has to do with the last lesson that we just finished on distributive property. So when we are simplifying or trying to get something in its smallest form, there's actually two things that need to happen. So an expression is simplified when there are no parentheses, and all like terms are combined. So we just talked about the putting together the like terms. So what we were working with was the second step. The first step, the other part, there are no parentheses. That's where our distributive property comes in handy. So sometimes you might have an expression where before you can put your like terms together, you might need to rewrite it using distributive property so that there are no parentheses. So generally when you're simplifying, you'll do things in the order that we wrote the steps out. Make it so there's no parentheses first. That way you don't accidentally violate order of operations. And then look for like terms that you could put together. So, for example, this would be an example of an expression that's not starting out simplified, but we could do some things to put it in its simplest form. So this expression has parentheses, which means we would have to deal with the there are no parentheses step first. So we could do some distributive property with this, which basically means each individual piece needs to get multiplied by 4. 4 times Q is 4Q. 4 times 8P would be 32P. So that's that part rewritten. And then we have this plus P hanging out at the end, which is still hanging out at the end after we've rewritten it. So basically, we rewrote that piece and we had to drop it back in with the rest of the expression of the plus P. Now that we don't have parentheses, now we could look for like terms to combine, focus on that first step. So in this case, this and this both have the same variable. So if I look at the coefficients, 32 and 1, I could put those together and make that a 33P. So 4Q plus 33P. Or if you wanted to follow our ABC order unspoken rule, you could use commutative property to flip that around and say 33P plus 4Q. And that would be your final answer. So that's an example of a problem where you would need to use our distributive property from the last lesson combined with what we were just talking about how to spot like terms and how to put like terms together.